Okay, perfect. Let's kick things off. So Kubernetes and MLOps for scalable and reproducible generative AI workflows. A bit of a mouthful of a title, I have to say, but I came up with it and all conferences have wanted it so far. So works for me. I guess it's descriptive enough. Before we kick us off, there won't be too much audience participation, so no worries if someone wants to just enjoy and be silent. But who here considers themselves a DevOps professional in some level? No one? Who considers them? Oh, well, one. Good. Okay, some level, emphasis on that. Who here considers an AI or ML person? Good couple. And then who's just a general coder, okay, most people. Well, that's good, that's cool. And you're both, that's fun as well. But that's good because honestly, this has hopefully a bit of small things for everyone. And mostly it's about kind of the intersection of DevOps and ML and AI and coding and technology and whatnot. So that's actually a really good mix, I have to say, because my number one fear would be that if it would be filled with super deep AI people, that it probably would be okay, maybe they would learn more about DevOps then. So that would be fine as well. So I take it back. Everyone is welcome. That's good. Awesome. But that's a bit of a teaser already on what this session will be about. So we're going to be talking about MLOps, how does it power generative AI, how does Kubernetes work in all of this, how does Kubernetes itself actually help MLOps, AI, and so forth. So those are some of the topics that we'll be covering today. I do have an agenda coming up with a bit of a more precise schedule as well. So who am I? Why am I talking here? So I'm Annie Talvasto. I'm a CMO at Vision, which is a Swiss DevOps company as well. I'm a CNCF ambassador as well as an Azure MVP. And those two essentially just mean that I just love everything cloud native, Kubernetes, containers. And I just love talking about them to people constantly all the time, whenever anyone will hear me. I'm also a Kubernetes and CNCF meetup co-organizer since 2017. For Finland, I live in Zurich nowadays. I've also coached early stage startups. I also host a Cloud Gossip podcast as well, co-hosted. And I've also been a track chair at KubeCon plus Cloud Native Con, both North America as well as the Europe one and so forth. And then I've also been hosting Cloud Native Live, which is a weekly CNCF live stream since I think 2021. All the year starts blurring in together, but it's all right. So that's kind of some of the reasons. And also a big fan of NDC London as well. It's always fun. So a bit of a deeper agenda here so that we know exactly what we're going to cover. This is the introduction. We're already doing it, so we're doing well. Then we have some definitions. I personally, I'm always definitions, oh, that's boring. But I think particularly in this AI, ML hype space, I think we do need to kind of consider the definitions a tiny bit so that we know what are we actually talking about together, so that you're kind of covering our bases in that way. Then we have why AI and ML is actually different from quote-unquote traditional engineering. Then we have some Kubernetes and MLOps and how do these things play together. Then we have some Kubeflow, a bit more of technical examples, product tooling examples. And then we have some best practices as well for all of these. And then we have some considerations because there's always, some hidden meaning deep and hidden somewhere. And then we have the wrap-up and resources. But I was thinking, okay, this is the agenda. That's how it looks like officially. But to make it a bit more fun, we're going to treat it as a treasure map. And obviously, at the end of this treasure map, we have scalable and reproducible generative AI workflows as our goal. So hopefully, we're going to land on the X marks the spot, at the end of it. And we'll have our little companion, which is this fun little robot, moving with us throughout the journey. So if we kick off, we're going to move on to the first portion, which is the forest, rainforest, one of these, which is the definitions. So jumping straight into it. So AI itself, artificial intelligence, refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. Okay, very hot topic, very widely used, but that is kind of what we talk about. So it really involves the development of computer systems and algorithms that can perform tasks that typically require human intelligence. So solving complex problems, making decisions, and learning from experience. On the other hand, our little robot is moving deeper. ML is the subfield of artificial intelligence that focuses on the development of algorithms and statistical models that enable computer systems to improve their performance on a specific task through learning from data without being explicitly programmed. So it really kind of allows computers to identify patterns, make predictions, and learn from examples and experiences. So those are the two big definitions there. Data scientist, on the other hand, data science, very big word as was big data and whatnot, like very trendy a few years ago. It hasn't gone away at all. Like, if everyone's like, oh, is data science going away? No, it's not. But it has fallen a bit off on the trend, like charting, if you consider. Like, for example, the job postings for data scientists have gone down, which would be, I think it's like an interesting notion because the AI hype is higher than ever, but actually data scientist roles are going down a bit. But that's mainly, I think, because we are switching from one hype word to kind of another. So also a lot of the roles that might have been posted as data scientists before, they might be now ML engineers or any of these other ones. And it also tells you about the maturity and the kind of growth that the ML and AI industry is doing, because it's anytime you have these kind of booms, obviously things are a bit wild westy in the beginning, or like, you have to kind of mature and so forth. So these terms might change and fluctuate, even though the skills and the people are relevant there. Then we have DevOps, which is short for development and operations, which is a set of practices, principles, and cultural philosophies that aim to improve and streamline collaboration between software development and IT operations. So it's all to do with developer operations, so DevOps. And then MLOps is machine learning operations, which honestly, you can kind of say, in a very crude terms, is that MLOps is DevOps, but with data. And that's usually kind of a simplification of it in a lot of ways. Obviously, it's not that simple in reality, but there is a bit of like a, if we kind of, simplify things a bit, that is a view that we can take on it, which is why I think actually the difference between MLOps and DevOps is the crucial out of these definitions in a way, because we have to recognize also that there is a lot of learnings that we can take from the DevOps world, but also we do have to modify and apply them to the specific scenarios that where I'm going to be kind of talking through in this presentation as well. So that is the definitions part. I hope it was quick enough so that no one was like, damn it. But I think it's important to run through these things sometimes. So why is AI and ML different than, we're going to go now to the mountain area? I'm very interested in what's going to happen in the school area, at least. That's going to be fun. So differences with AI and ML to traditional engineering, quote unquote. I feel bad saying like traditional engineering, because I think engineering as a field is relatively new on its own, rather than, obviously, engineering around, actual other things than software and Kubernetes and DevOps and so forth, but still. So what are the big differences and why does the MLOps and DevOps differentiate from each other? So it is data-centric in nature. So ML and AI are data-centric. So the quality and the quantity of data significantly impacts the performance of the models. So this means that ML and AI engineers need to focus on the data collection, pre-processing, and feature engineering, which are really not as central in traditional engineering. So this really changes the game a bit there. The other big one is model complexity. So in regular engineering, systems are typically designed to be built all around according to well-established principles and specifications. So in contrast, ML and AI models are complex and their behavior is learned from data, as we learned in the definitions part as well. So engineers must really experiment with various model architectures, hyperparameters, and training data to optimize performance and more there. Iterative development, it is a buzzword in DevOps world in general, but it is absolutely crucial in the ML and AI world. So, because the development is often highly, highly iterative, because engineers continually have to experiment, fine-tune models, and retrain them to achieve desired outcomes. So traditional engineering projects tend to have more predictable and linear development processes in general. Scalability is a big requirement as well. So ML and AI solutions often require scalable infrastructure to handle large data sets and computational demands. So this may involve distributed computing frameworks like Spark, GPU clusters, and cloud-based resources. So traditional engineering does not usually have this exact. There might be scalability scenarios for traditional engineering, obviously. I'm a Kubernetes person. I am very aware of that, and I love all the scale. It's good. But there is, obviously, inherent scale usually built into AI and ML. Monitoring and adaptation is a big one as well. So ML and AI system itself require ongoing monitoring to detect issues like model drift, data quality changes, or shifts in user behavior. So engineers must really build systems that can adapt to these changes in real time, whereas regular engineering systems may not need such dynamic adjustments as well. So testing and validation is a bit different as well. So in regular engineering, quote unquote, testing and validation can be based on established standards and specifications. So in ML and AI engineering, then testing often involves evaluating the model performance against specific metrics. So validation may require the more domain-specific expertise and may not really have a clear-cut, pass and fail criteria. So it's a bit more complex there. Explainability and bias is a big one. I think we do usually in tech, we are, we understand, these things, that there is inherent biases in these things and we need to have explainability, but these are so much the importance is heightened in AI and ML because it's really important to understand why an AI model makes a particular decision, especially in critical applications. So like healthcare, finance, anything where you're actually involving human lives in any manner where the AI would be involved in recommending or making decisions or in anyhow affecting, it's obviously incredibly crucial, which might be not as prominent in normal situations. And the big one, I think, that affects these kind of presentations that I do as well, there's so much rapid advancements in the field. So the field is rapidly evolving with new techniques, libraries, and tools really regularly emerging. So staying up to date is a bit of a challenge as well. And also, to be honest, from my side, particularly like now, it's also because we are expecting a lot of rapid advancements in the future. Finding good best practices right now can be a bit tricky because it's still a bit of a wild west occasionally, because when new fields develop, you have new tooling, maybe you have new capabilities, but no one has tested them truly at this point necessarily to a certain extent. At least in all specific scenarios and so forth. So then that it might be harder to even get that information, let alone, if you know where the information is, keeping up with it and constantly re-educating yourself. Collaboration is a big one as well, and that is obviously like if you listen to any sort of, for example, panel where even the biggest companies talk about, okay, what are the challenges that they face in doing AI and ML? It's a lot to do usually with collaboration as well as like interdisciplinary skill checks and everything like that, because everyone who's working on these projects usually have very deep expertise on an area, but then getting everyone collaborating, getting everyone talking, getting everyone to understand each other's fields in a deep enough way, that's definitely usually one of the challenges that you face. Because there's data scientists, software engineers, domain experts, so finance or healthcare and so forth, and infrastructure engineers. So there's so many different people with so many varying kind of experiences in the background. Deployment challenges are one as well. So deploying models into production requires special considerations. So engineers must ensure that the models are served efficiently, can handle real-time requests, and integrate with existing systems. So engineering systems in a traditional way may allow more established deployment processes. So it's a bit of a different there. And I think one thing that we all probably nowadays consider about, hopefully in these maybe not economical channels, I don't know what's the best word for it, but at the moment I think all companies are very aware of costs, and ML and AI development particularly is not cheap at all. So you really need to focus on it and think about it. And with the GPU shortages as well, getting even a GPUs to do even like basic stuff, it's actually quite challenging sometimes. because of the specialized hardware and the resources and so forth. Like, for example, I spoke about ML in KubeCon recently, and I attended a lot of the AI and ML track sessions as well. And I think like about half of the speakers were talking like, ooh, I really wanted to do a cool demo, but I couldn't get a GPU resource. So if even like people from big companies who are doing a KubeCon talk can't get a GPU in a sensible time and with a sensible budget, you know, what's the chances for the rest of us? But hopefully there's going to be improvements on that, because that was a big topic, GPUs, and actually, you know, using them in the maximal and most optimized way was a big topic within whole of KubeCon as well to help with this. But yeah, these are some of the differences that you have to consider while you're going into this practices, because truly getting from research, so like model development, to production is a huge hurdle within the ML and AI space. So I think normal people or regular developers, tech people and whatnot even, if I talk with people and I ask like, okay, what do you think is the bottleneck in AI and ML development and so forth? Usually people the gut feeling might be that, it's probably in like developing the really cool, complex AI models and so forth. But that's actually not the kind of reality right now. So reality is that over 50%, it could be, I think the number was even like 70 or something, but I don't want to quote on to a number, but it was over 50 of models never make it to production ever. So we have actually a good amount of models that would be good in production, would work there, could maybe provide some benefits, but the research to production flow, so getting actually over the DevOps and the infrastructure hurdles is a major bottleneck right now. So that is not a given. So you do have to kind of consider a lot of considerations when you're going through that road as well. It all starts from, data scientists, for example, when they are developing. And also as far as the timing goes, developing a new model that needs to be going into production it can take, for example, a couple of weeks, but getting things into production from there might take months and months, as well as like multiple people who are working on it. So that's one of the reasons why also it's a bottleneck. It requires a lot of effort as well. But it starts with usually a data scientist, for example, working on Jupyter notebooks, just creating on their own. But then when you need to package it to go to production and so forth, it needs to switch to microservices. You really need to think about the dependencies, parameters, run scripts and builds. So there's a bit of a disparity there, kind of from the Jupyter notebooks, from the data scientist to production is very much like a bottleneck. Then when you move on to scaling out, you think about load balance and data partitions, model distributions, and so forth. And data itself requires multiple things, so not just load balancing. So you need to consider data partitions and so forth. You need to tune your models as well. So things, if they're not built for latency, someone has to consider it and have to build for it as well. You have to instrument, you have to add monitoring, logging, versioning, and security. And this kind of goes beyond regular Kubernetes or container monitoring as well, because in addition to the regular things that you have to monitor, performance and so forth, you have to monitor data as well, which is then again, when it goes to production, the Kubernetes people might not be as well equipped to deal with these data things, which is then again adds more to the time and adds more to the challenge and considerations. So then automation is a big part of this, and I think when moving to production, you have to automate things and you have to build CI/CD workflows and rolling upgrades into your systems, and we don't obviously want to just repeat things manually constantly. So it's all about getting people to work together and actually, collaborating together, which is very DevOpsy in its own way. Perfect. So now we have learned why is AI and ML different and what does it kind of actually mean? What are the hurdles that we have to face and what are the things that we're actually solving for when we're solving these issues? So why then, moving on here, we're going to go to the next, we're going to go to the C. So Kubernetes and MLOps, why that then? Actually, even it is interesting and fun for me sometimes because even very seasoned Kubernetes people might come up to me and ask, you're talking about Kubernetes and MLOps. Why? Like, what do these things have together? Well, they have everything to do together, to be honest. So You can do obviously ML and AI and all of these things without Kubernetes as well, but Kubernetes offers a great platform to use with a lot of benefits to do as a platform for your AI and ML workflows. ChatGPT itself, so OpenAI uses Kubernetes, and there is a interesting, it's a bit of an old, it's like 6 years old or so, KubeCon keynote with where OpenAI talked about how they use Kubernetes and how they actually used it and so forth. So there's resources if you are interested in how that was built as well. But why is Kubernetes then such a good fit? Why does it work together? Because there's a host of them, a list of reasons essentially. Portability is a big one. So Kubernetes itself provides a consistent and portable platform for running machine learning workloads. So ML models and their dependency can be containerized using Docker and making them highly portable across different Kubernetes clusters. So they can even run on various cloud providers or on-premises environments as well. So you can develop and test ML models in one environment and then seamlessly deploy them to the next one, for example. So migrating ML workloads is also easier between different cloud providers as well. Customizability is a big one. Kubernetes is highly customizable, allowing you to really tailor your infrastructure to your specific ML needs. So you can configure resources, networking, storage, and security settings to match the requirements of your machine learning workload as well. So customization then again enables fine-grained controls over resource allocation and ensuring that ML models then receive the appropriate amount of CPU and GPU resources. And you can also set up custom environments and configurations for different stages of ML workflow, from development and testing to production deployment as well. Performance is one as well. If you're familiar with Kubernetes, scaling, performance, all of these things are household stable names there. So Kubernetes itself offers performance benefits for ML workloads through efficient resource management, so scaling and load balancing, and it ensures that ML applications can scale horizontally to handle high demand scenarios. And with, for example, with Kubernetes horizontal scaling, so horizontal pod, auto-scaling allows ML workloads to automatically adapt to varying levels of demand and maintaining responsiveness. And efficient resource management minimizes the resource contention, ensuring the models receive the necessary compute resources to perform optimally then. Consistency is a big one as well. So Kubernetes enforces the consistency by providing a standardized and consistent environment. So it reduces the risk of disparities between development and production environments as well. It's also a consistent platform for model training, serving, and monitoring. Microservices, they help by breaking down ML applications into smaller, independently deployable components, so that then the modularity and the flexibility in ML workflows makes it easier to update and scale individual components, as well as orchestrating microservices as building blocks really helps you there as well. Composability is another one. So ML workflows, this really helps with end-to-end ML workflows in particular. So you can define, share, and reproduce ML workflows as code, enhancing the collaboration and the efficiency, which I also talk about. The collaboration is a tricky one as well. And by composing ML workflows in Kubernetes, you can easily integrate various components like data processing, model training, and model deployment into a cohesive pipeline then. So there's a lot of host of benefits. And Kubernetes itself works really quite nicely. And I was just checking up on the latest big organizations who are using and talking about doing ML in production and so forth. And it's essentially that if you're doing very basic, very small scenarios, then you might not need Kubernetes. But if you're building up for any sort of maturity or building up for scale, particularly for ML and AI, Kubernetes is quite often the must-go for mature organizations or projects. And also, I like to emphasize that for normal, traditional engineering, I don't recommend Kubernetes for every case, and I don't even think Kubernetes is always the best fit for everything. But I think particularly with the scalability needs and all of these different needs for ML and AI, it's quite often a really good match there. But then, as the Kubernetes works as the kind of underlying infrastructure for these things, there is still a bit of challenges there, and just using Kubernetes own will definitely not solve your issues, because the collaboration aspect, Kubernetes doesn't really help. It actually might hinder a bit of that, and not in the way that Kubernetes itself would destroy collaboration among teams or people, but in the way that Kubernetes is quite tricky to use. So it is actually, I think, a good saying that the best way for a data scientist, for example, to use Kubernetes is just not to use it at all, essentially. So you want to create situations where people can tap into the power of Kubernetes and use the benefits, but not necessarily that they have to expose themselves to managing Kubernetes and using it, because then, the threshold for skill building will be quite high, which is where Kubeflow comes in. Which is why we're going to move to the next for us there. And we're going to talk a bit about Kubeflow. How many here has heard about Kubeflow before? No one. Perfect. Well, then we're all going to learn something new, and that makes me very happy. That's good. So Kubeflow is the machine learning toolkit for Kubernetes. It's a CNCF project that is within CNCF, so Cloud Native Computing Foundation. So it's an open source project. It's fully, you can use it for free and so forth. So there's a lot of nice things there. So it's designed to make it easier to deploy, manage, and scale machine learning workloads on Kubernetes specifically. And it provides a set of tools, frameworks, and best practices to streamline the development and deployment of machine learning models in Kubernetes environment. So what is it? Then kind of continued a bit deeper. So it provides that end-to-end ML workflow. So Kubeflow offers a unified platform that covers the entire machine learning workflow, from data pre-processing and model training to deployment and monitoring. So the cohesive ecosystem then reduces the complexity and managing different tools and components separately as well. It provides help with scalability and resource management. So as you can use Kubernetes really efficiently in the background, it helps you leverage the Kubernetes organizational capabilities, orchestration capabilities. So Kubeflow enables easy scaling of machine learning workloads, and you can dynamically allocate resources based on demand as well. It also really helps with reproducibility as well as collaboration. Like the hardest word to say, by the way, I guess as a non-native, reproducibility. And Kubeflow's infrastructure really helps here. So it encourages best practices for reproducibility by capturing metadata, environment details, and code versions associated with each experiment. So it helps with collaboration among data scientists, engineers, and researchers, which you can tell is starting to be a bit of a theme across all of these ML AI challenges, is the collaboration aspect of it. And if this tooling can help, it usually works really well. There is obviously scenarios when you should be using Kubeflow, and then there's scenarios maybe that they are not the best fit. Really good scenarios are, for example, if you're building and deploying machine learning models and applications that require the scale and help that you need from there. Sometimes I speak with people who say like, oh, they tried Kubeflow for their organization, but it didn't really bring benefits. Well, then it's usually the case with all Kubernetes tooling. If you have the scale and if you have the complex needs that you need an extra project to manage these things, then it makes sense. But with a lot of the CNCF Kubernetes add-ons, you are adding complexity to your infrastructure by introducing a new tool. So you obviously have to make the decision that is your pain big enough so that you add more complex situations so that you will have a bit of an extra hurdle, but if it helps you, obviously, on the long term, then that makes sense. And particularly, I think, for ML and AI scenarios, Kubeflow, for example, makes sense because it does help with that collaboration, and it helps you. And for example, if you have data scientists in your teams, if you are managing the Kubernetes side of things, it helps to not expose them to the Kubernetes side as well, and so forth. Because you can use Kubeflow without much knowledge side, if you have it configured currently, and so forth. So how does it then kind of be continued work? So Kubeflow really includes, for example, notebooks, so to manage interactive Jupyter notebooks as well, and you can customize your notebook deployment and your compute resources. So you can experiment with your workflows locally and then deploy them to the cloud when you're actually ready. It provides TensorFlow model training, so it provides a custom TensorFlow training job operator that you can use to train your ML models. It has model serving as well, so it's also integrated with Seldon Core, NVIDIA Triton interface server, and so forth. So there's a lot of different things that you can do with it. It has Kubeflow pipelines, which is a comprehensive solution for deploying and managing end-to-end ML workflows. And you can use them for rapid and reliable experimentation. So you can schedule and compare runs and examine detailed reports on each run. It supports multi-framework, so there's a lot of help there. And as it is an open source project, it also has a very active community that can work around it as well. So this is, for example, how things would look like without Kubeflow when you're doing ML and AI development. So you have the experimental phase there where we identify problems and collect and analyze data, choose an ML algorithm and code your model, experiment with data and model training, tune the model hyperparameters, transform data, then on the production phase, train model, serve the model for online, and so forth. So it's always an iterative loop, obviously. With Kubeflow, it's going to look like this with all the tooling that I just also kind of mentioned. So you have everything from PyTorch to TensorFlow, helping you along the way and really kind of, managing the process for them. Now, if you're wondering, okay, that sounds really good, all sounds good in practice, how does this actually work in the real world? How does this actually, is there any examples of organizations using it? Shell is using it in production, essentially. For a reason, I've taken a screenshot with the name of the session. I will provide a link to it at the end in the resources portion, but I think this was actually a really fun session by Shell. It was a KubeCon keynote where they talked about using Kubeflow and why they selected it, what were the pains that they had, and how it has helped them. And it's just like a kind of nutshell or like a summary of some of the things that they talked about as well, like actually using this in practice. They had a lot of the same challenges that I've been talking about today. So disparate and inconsistent dev environments. So creating proper dev environments was tricky. So working with local data is quite easy sometimes, or you can manage it, it's easy. But when you're using large data sets from global sources, like you can imagine the scale of Shell and their data sets and their data sources, it definitely becomes a bit of a challenge there. And then they had also a challenge with requirement for too many specialized skills. So the environments required a lot of specific skill sets. And again, those issues of, data scientists working with Kubernetes and vice versa, it's always a bit of a hassle. And then wasted or underutilized resources. And I really like the quote they said, like, we can't bankrupt the company. And that was like the base of it, because truly, those are some of the things that you have to consider when you're thinking about the scale and data sets of ML and AI. So it is an actual concern. Let's not bankrupt the company, essentially. And Kubeflow solved these by helping with secure cloud hosting and self-service. So they could do rapid onboarding at scale. So with the self-service model, data scientists can grab computational power and use pre-configured settings. So what before at Shell used to take just months and months of setting up things and people working. Now it just takes minutes for them to get self-service onboarding for the data scientists, for example, working. And Kubeflow automated pipelines, engine Kale also helped with them, so they could easily turn notebook code into a scalable pipeline much faster. And then shared cloud resources helped as well, so they could accelerate model training and development and deployment. So you can monitor the notebook servers and see how much compute they're using, and then release compute if needed, because if someone's using more or less, then you obviously need to kind of play from there. Then we have the next portion, which is some best practices to share for everyone. There we go. And it always starts with data. AI and ML, it always starts with data. No matter how great of a setup you have, no matter how great of a production, however, if your data from the get-go is wrong, you're going to go to a wrong direction from there. So that is obviously always the king. Mastering all the necessary skills is also a big one, because I've been talking about the skill disparity and the collaboration issues that people might face a lot here. So if you are thinking about or you want to learn more about these topics, you quite easily will face yourself into learning about new things. And now for DevOps professionals, that might be more in the, okay, I need to learn more about AI ML. For AI ML folks, it might be learning more about DevOps. It might be learning how to use a Linux command line and so forth, about cloud, bash shell commands and so forth. And whatever your background is in tech or non-tech, you have to kind of consider these, and you have to think about where is the intersection of where your skill set lies and what do you need to kind of add on to it to really, really build upon the skill set so that you can kind of, get to the next level as well. And then know the tools and you need and choose them wisely, because honestly, with a lot of these things and with Kubernetes, it's always very easily easy to get sucked into I'll add that tool, I'll add that tool, I'll add these things. But it helps to actually really think about what do you actually need and when do you need it and for what usage case scenario do you need it for. There's a host of things that you can use. So obviously all the big cloud providers have their own cloud native ML platforms. So for example, AWS SageMaker, Azure ML Studio, GCP AI. But then there's also platform containerized workflows. So from Docker to Kubernetes and so forth. And obviously you can use serverless as some of the background as well. So from AWS Lambda to Google Cloud, Azure Functions and so forth. So there's a lot that you can choose from, but obviously always consider what you're going to use and why are you going to use it so you don't end up adding complexity to your environments that you don't need, that's going to actually be creating more of a challenge than the problem that they're solving itself. Understanding the bottlenecks that you have. I talked about that the production might be a bit bottleneck, and it is a big bottleneck in the industry as a whole. But considering that, then thinking, okay, where are the bottlenecks within my own organization, within my own project? That is obviously super important, and figuring out from there. And the cross-collaborative skill sets helps with this as well. MLOps, hard DevOps, I think it's a really, really big one. So if you are kind of stuck and you don't know how to manage MLOps, how to do MLOps in general, you can usually quite easily start with DevOps best practices and build from there. Now, this is also part of the fact that the industry is not as mature as the DevOps industry. So likely along these next even months, to be honest, because there's rapid advancement sometimes, within the next years, we're going to see more and more specialized MLOps practical advice and lessons learned from really big use case scenarios and so forth. So it's going to just, there's going to be more and more information coming in. But for now, we can kind of treat like the MLOps pyramid of knowledge, so you can really see that the big foundation is a DevOps knowledge and DevOps best practices that you can tap from there. And obviously you can use AutoML and Kaizen and gazillion other tooling as well to help with your use case scenarios and so forth. Then we do have a bit of about DevOps, mostly because if people would be interested in kind of recap of what are actually the DevOps best practices, because I recommend here use DevOps best practices. So just quickly going to run through these. Or is everyone super familiar with DevOps best practices and don't want to handle this slide at all? Raise your hand if you don't want to hear any DevOps best practices at all. Okay, everyone wants to hear, maybe, or no one wants to raise their hand. It's a quick slide if someone's like, I don't want to hear it. So automation is a big one that you really need to consider when you're doing DevOps that helps with these. So this is one of the things that you would need to, again, implement there. So as I mentioned in the traditional engineering parts, CI/CD is an important one. So automatically integrating code changes from the multiple developers into a shared repository multiple times per day, for example, for continuous integration. And infrastructure as a code is a great thing that you can really start using as well. So that treats infrastructure configuration as a code and allows infrastructure components to be provisioned and managed using code actually itself. So Terraform and Ansible are some of the tooling in this space. Monitoring is highly important because obviously if you are not monitoring and you don't know what are the metrics and the monitoring tooling that you're using, or kind of, how can you make improvements iteratively or automate anything if you don't know what are you actually doing and why, essentially. Continuous monitoring is super important on that front. And then culture, collaboration, and comms is a huge area of DevOps as well. So it promotes the culture of collaboration. And in here, honestly, some of the best practices can be as simple as just using a collaboration tool like Slack or Microsoft Teams or something. That's very common sense practices as well. Version control as well. So using Git, for example, that are used to track changes among team members and the ability to roll back changes if issues arise. Security is important as well. So rolling in all the best practices from security realms and so forth is highly important as well. And some of the things that you can obviously try, I already mentioned, you can use Git, you can do Even just using different collaboration tools is important. Then for a lot of these things, auto-scaling, for example, is a DevOps best practice. So from the Kubernetes side, you obviously have cluster autoscaler, but you can also try out Kada, which is event-driven auto-scaling for Kubernetes that scales up and down on an event-driven basis as well. And for example, for security, you might think about implementing role-based access control, so RBAC as well. So there's a lot of host of these. But one thing is for sure, if you can't find too much MLOps best practice material from the internet, you can find a good amount of DevOps best practice information. So there is no lack of information as of right now. So there's a lot to tap into there. So we're starting near the end. We just hit the mountains there. And then we're going to move actually to the school area right now because we have ethical considerations to think about. And I don't know if this is everyone's favorite or least favorite topic, but I think it's super important to actually, when we're thinking about AI and ML, to put ourselves into the mind space that we have to start thinking about these very carefully. Now, in regular or coding or regular DevOps, you obviously have to think about ethical considerations, but the impact of the decisions that you make might not be as far-fetched in a lot of cases than with AI and ML, particularly if you don't have that visibility or transparency set up as well as it should be into your models, so that then you might end up with, really blind spots and bad biases there. So fairness and bias is one of the cornerstones here. So you really do have to address bias in data and algorithms to ensure fairness in AI and ML systems. So some of the actions, like concrete actions that you can take here, is regularly audit data for bias, implement bias mitigation techniques, and strive for representativeness in your training data sets as well. Transparency, so it's really critical to build trust in AI systems as well for users, for example. So you have to document your model architecture, data sources, and decision-making processes, and then implement explainability techniques to make AI models more interpretable. Then we have privacy. So, this is a big one that I think everyone in even traditional engineering has to consider. So respecting user privacy and protecting sensitive data is important. And some of the things you can do is implement data anonymization, consent mechanisms, and data access controls, and obviously comply with GDPR and all the other relevant frameworks. Honestly, the minimum requirement, obviously. Accountability is an important one as well. So developers should really ensure that AI systems are accountable for their actions. So you have to establish clear accountability frameworks, conduct regular audits, and document the roles and responsibilities of AI system owners and operators. Consent and user empowerment is one as well. So users should have control over the interactions that they have with AI systems. So you have to clearly communicate the capabilities and limitations of AI systems to users. So offering opt-in, opt-out features and user-friendly interfaces, for example. Security. No one hopefully is a complete stranger to security, even if they have never touched ML or AI spaces. But it is important, so obviously robust security measures and all of these things are really important. Human-centric design is, I think, a very good point as well. So prioritizing human well-being and safety when designing the AI systems is important. So involve multidisciplinary teams, including ethicists and domain experts, so that you aren't just creating technical projects from that perspective, but actually include the people who would know the repercussions of the decisions that the AI models take. Data governance is important as well. So you should establish a responsible data governance practices. So data should be collected, stored, and used ethically and securely. So then you have to implement data governance policies and assess data provenance and adhere to data handling best practices. And regulatory compliance is usually the bare minimum as well, but obviously really important. And you have to stay quite informed with the evolving regulations and ensure that AI systems comply. And particularly around Europe and European users and dealing with these things, there's a host of AI regulation likely coming in the future. So these are particularly things that you really do have to stay on top of as well. But that was a big portion on ethical considerations. Then we have actually some learn more resources here to link to you. So I'll add my link and slides to my GitHub as well, but obviously NDC also usually records the sessions, so that might be available later on as well. if you now are sitting here and you're like, oh, that was good, I'm interested to learn more, but I would have loved to see more like practical code examples or like, how to do everything in a very, very practical sense. This book, Practical MLOps by Noah and Alfredo, is a great resource for that. I bought it, I like it a lot. It has all of those, like a couple hundred pages on exactly like what is the command that you do first and how do you actually, do everything step by step in a way. Highly recommend that as well. It's from O'Reilly. Then we have, I recommended the Shell keynote that I mentioned before, if you're interested more on learning about Kubeflow for machine learning. So Holden Crow, I think, works at Netflix at the time of this session came out. So there's some interesting stuff from their side on how they use things. And then there's a webinar on MLOps automation with Git-based CI/CD. And then KubeCon has if you're interested in the intersection of Kubernetes, MLOps, DevOps, ML, and AI. So Kubernetes has had for multiple years now a Kubernetes AI Day within KubeCon, like as a co-located event. So they have great sessions in those playlists as well. And the one that I highly recommend is this one which is the welcoming and opening remarks, the state of production of MLOps in Cloud Native. It's like 45 minutes simply talking about, what's happening, what are the trends, what is going on, and so forth. So if you're interested in that side of things, highly recommend that one. Sadly, the voice is I think their mic was a bit off or something in the beginning, but you can still kind of understand that. It gets better actually, I think, at the halfway point-ish. So I don't know, I guess they figured out to turn the correct mic on or something at that point. You can clearly hear it in the session. But those are some of the recommendations that I had there. So then, as you can see, we even covered the school area, so we managed to handle that, which was the ethical considerations. Scary, but important. And then we can move on to the X marks the spot, which is the treasure, which is obviously now our happy little robot can get the treasure, which is the scalable and reproducible generative AI workflows, and obviously managing these and achieving them in your own organizations and projects as well. But that's it from my side. Thank you, everyone. And this is just fun, even though this has been solved a gazillion years ago, but it is still fun, and I just find the picture very enjoyable. I hope everyone had fun, and I'm gonna let you, I think, run to you don't have to run, you can come talk to me here and ask questions if you want, but I think it's lunch up next, so we can get a bit of a head start and don't have to stand in line endlessly. But I can take questions as well now if everyone has any, but I'll be here as well if you wanna ask a secret question, I don't know.
Do you have any thoughts on MLflow, which is another alternative for Kubeflow?
Yeah, I think there is, you can use it. There's no issues. I have nothing against. I'm not going to say either one is better because it depends your exact use scenario and it depends on what are you looking for. As a person who's very much into Kubernetes and open source, Kubeflow is kind of my favorite, but does it mean that I would use Kubeflow for every single scenario out there? Not necessarily, because I am a big proponent for not going in blindly for something that's hyped up or you might even personally like or something. You have to think about the exact scenario that you have and what are the needs that you need really met and so forth. So,
okay, is there more adoption for Kubeflow or
more adoption?
The way I'm searching is I see more adoption for MLflow than Kubeflow. I don't know what's the reason driving behind that.
Well, there's usually a lot of host of different reasons. Kubeflow itself it's been around for a bit, but it's still, I think, because it's an open source project and I think it's in the incubating phase. So definitely it can mature a lot more and it can kind of grow a lot more, but that's the case for a lot of open source. And also, to be frank, there's been a bit of a race around open source towards AI and ML projects in general, because it was maybe not always, well, it was always been focused. KubeCon and all of these events have always covered it, and it's been always. But I think with the rise of the hype around these topics has added a lot more contributors as well, which is likely going to lead to catching up more down the road for open source projects around these topics. But it does obviously take a bit of time to people to actually contribute and help out and move forward within the spaces. Yeah.
Right. Yeah. Thank you.
Any questions? Please remember our feedback boxes. They're outside both of the doors, and we really appreciate that. And can you join me in thanking our speaker?